Hello, this is Mrs. Ward, and I am going to go over the review worksheet for sections 9.6 and 9.7, polar coordinates and their graphs. So the first one, you have 3, 4 pi over 3. So I like to find my angle first. So 4 pi over 3 is down here, and my radius is positive, so I'm going to be somewhere on that line. And I want to go to a radius of 3. I'm looking at my scale over here, and I'm going to plot that point. Okay, next one is 330 degrees. Well, here's for 30 degrees, going out 3 radiuses, and there's my dot there. Number 3 is also 30 degrees, but it has a radius of 1, so it's going to go right there. And finally, I have 3 pi over 2, which is this angle down here, positive 4, and there's my dot. Remember, if it's negative, you hop the pole and go on the other side. The next one, you convert each pair of polar coordinates to rectangular coordinates. If the angle is on the unit circle, then we expect you to give us the answers in radians and fractions, no decimals. So number 5 is on the unit circle, so I'm going to do 5 down here and say x is equal to r cosine. Well, r, let me put in r first. R is 3. So x is equal to r, which is 3, times the cosine of 5 pi over 3. So x is going to equal 3 times the cosine of 5 pi over 3 is a positive 1/2, and I'm going to get 3 halves. Y is equal to 3 times the sine of 5 pi over 3. So that's going to be 3 times the negative square root of 3 over 2. And so my final answer is going to be negative 3 times the square root of 3 all over 2. So that ordered pair is a positive 3 halves. Negative 3 square roots of 3 over 2. Okay, number 6, I am going to do x is equal to 1 times the cosine of 7 pi over 4. So x is equal to 1 times the square root of 2 over 2, and that's positive because it is in the fourth quadrant. Y is equal to 1 times the sine of 7 pi over 4. So y is equal to 1 times a negative square root of 2 over 2. Don't really need to multiply by 1 because it is 1. So it's a square root of 2 over 2 and negative square root of 2 over 2. And that is my rectangular coordinate. Doing number 7, I am going to say x is equal to 4 times the cosine of pi over 6. So that's going to be 4 times the square root of 3 over 2. The 4 and the 2 will simplify, and I'll be left with 2 square roots of 3. Y is equal to 4 times the sine of pi over 6. So 4 times a positive 1/2, which will be 2. So my final ordered pair is 2 square roots of 3, 2. And finally, number 8, x is equal to 2, which is my r, times the cosine of 3 pi over 2. Well, the cosine of 3 pi over 2 is 0, so the x coordinate is also going to be 0. Y is equal to 2 times the sine of 3 pi over 2. So 2 times the sine of 3 pi over 2 is negative 1. So I'm going to get negative 2. So that ordered pair is going to be 0, negative 2. Okay, the next ones, you are taking the rectangular pair and you are changing them to a polar. So the first thing I'm going to do is find my r. So this is number 9. I'm going to say r squared is equal to x squared plus y squared. So r squared is going to equal, this will be a positive 3/4 plus a positive 1/4. So r squared is equal to 1. R is equal to 1. So my radius is 1. When I go to do the angle, I can do it 2 ways. First, I could do that. I should recognize it from my unit circle, but let's suppose I don't. So I'm going to say the tangent theta is equal to the sine over the cosine. When I do this, if I put in my calculator and I do it in degrees, I'm going to get 30 degrees. No, I'm not. I'm going to get negative 30 degrees. And that would be right, except for if you're doing your calculator, you get negative 30 degrees, except for this sort of pair, negative x and positive y, is going to put this in the second quadrant. This angle, if I did it in my calculator, I'm going to get an angle from the fourth quadrant. So in order to put it in the proper quadrant, I'm going to have to add 180 to that. So I could do 150 degrees, or I could do 1 and then 5 pi over 6. Either one of those is right. If you recognize it from your unit circle, you're probably going to go straight to the 5 pi over 6 because you're not going to even put it in the fourth quadrant. If you decide to keep the negative 30 degrees, which you can, if I decide to keep the negative 30 degrees, then since that angle's in the fourth quadrant, I'm going to have to make my R in -1. So any one of those answers, remember I can write it 4 different ways. Any one of those answers would be correct, except for now I'm reading the directions. Whoopsie, didn't read those before. It tells me R has to be positive and the angle has to be between 0 and 2 pi. So if I'm following those directions, which we should, that eliminates that guy right there. So you can either do 150 degrees or 5 pi over 6. Okay, number 10, I'm going to do down here. So 10, I'm going to say r squared is equal to -3 times the square root of 3 over 2 squared plus 3 halves squared. So r squared is equal to, that's 9 times 3, so that's a positive 27 over 4 plus 9 over 4, which will be 36 over 4. Oh, which will be 9. So r squared is equal to 9, which means r is equal to 3. If I'm doing my units, if I'm doing it, I'm going to say the inverse tangent. Let's just jump right to the inverse tangent. 3 over the square root of 2 divided by negative square root of 3. 3 times that over 2. And I do believe I'm going to get a negative 30 degrees again. And so again, this is in the fourth quadrant. I have to add 180 if I'm in degrees, and I am going to have 150 degrees. So I'm going to do 150 degrees, or I can have 5 pi. That's a really bad pi over 6. Okay, number 11. Let's just start this way. Number 11 is in the fourth quadrant. Just checking. So now I'm going to do r squared is equal to 2 times the square root of 2 squared plus a negative 2 times the square root of 2 squared. So r squared is equal to 2488 plus 8. So r squared is equal to 16. So r is equal to 4. Then to find my angle, I'm going to do the inverse tangent. The inverse tangent of a -2 square root of 2, over 2 square roots of 2, which will end up being the -1. You don't have to simplify that if you don't want to, but I did. And so when I do that on my calculator, I'm going to get theta to equal, I believe, a -45 degrees. So I can add 180 to that. Oh, do I have to add 180 to that? No, I do not, because it's in the fourth quadrant. So I'm not adding 180. But here's what's going on. I'm saying -45 degrees. So I'm saying -45 degrees, but it wants my angle to be positive. So I'm going to have to go this way. So I can either recognize it as 315 degrees. I can add 360 to this. All depends on how you want to do it. So this will end up being 4 was my radius, and then I can do 315 degrees, but if I'm in radians, I'm going to do 4 and then 7 pi over 4. And I guess since they say radians, I should do radians, but you know. So the last one is -2, -2 square root of 3. So this is in the third quadrant, so my angle is not going to be correct if I'm using my calculator. So I am going to do r squared is equal to -2 squared plus -2 times the square root of 3 squared. So this will be 4 plus 4 times 3, which is 12. So r squared is equal to 16. R is equal to 4. Inverse tangent of the sine over the cosine, and I'm doing this from my unit circle, so I would simplify to make life easier on myself. If I'm putting in my calculator, no need to simplify. When I do this, my calculator will give me 60 degrees. which is pi over 3. You should be able to do that. But that is in the first quadrant. This ordered pair is actually in the third. So I'm either going to add 180 and get 240 degrees, or I'm going to add pi and get 4 pi over 3. So my final answer for that one, my radius was 4. So it's going to be 4 240 degrees, or 4 pi over 3. Preferring the radians over the degrees. Okay, then and directions for 13 tells you that it is you're going to want to make a graph, a chart to plot the points. And it's first asking you whether what it's symmetrical to. So since it's a sine curve, I'm going to say that it's symmetric with respect to the line theta is equal to pi over 2. Since it's a sine function, just to remind you, that means I have this line at pi over 2. Whatever I graph on the left side will be the same thing on the right side. So when I go to make my charts using this symmetry as an aid, I am going to just do points from the first and the fourth quadrant. So let's say I do 0, pi over 6, pi over 3, pi over 2, and then doing the fourth quadrant. Those are all from the first quadrant. And then doing the fourth quadrant, I'm just going to write negative pi over 6, which is 11 pi over 6, negative 5 pi, oh, I said 5 pi over 3. Okay, let's just be consistent, call that 11. And then 3 pi over 2. So those are my points from the fourth quadrant. So when I go and do this, I'm going to do 0. So my r is going to equal 6 times the sine of 0 degrees, or 0 radians, whichever. And then that's going to be 6 times 0, which will be 0. Then I'm going to have r is equal to 6 times the sine of pi over 6. The sine of pi over 6 is 1/2, so this will end up being 3. R is equal to 6 times the sine of pi over 3. So 6 times the square root of 3 over 2, which is going to be 3 times the square root of 3. And then r is equal to 6 times the sine of pi over 2, so 6 times 1, which is 6. So that's probably going to be my max. But just to verify, I would find 3 pi over 2 as well. Now let's do the other, keep on going. R is equal to 6 times the sine of 11 pi over 6. So this is 6 times negative 1/2, so that'll be negative 3. R is equal to 6 times the sine of 5 pi over 3. So that'll be 6 times the negative square root of 3 over 2. There's a negative sign there, which will be negative 3 square roots of 3. And finally, r is equal to 6 times the sine of 3 pi over 2. So r is equal to 6 times negative 1, which will be negative 6. Wonder if my graph paper goes to 6. It does. Oh, good. So the only thing I'm going to do real quick is to help me graph is I am going to find the decimal for this is approximately 5.1. Let's call it 5.2 because it's 5.12. So this will be approximately negative 5.2. So when I go to graph this, I'm going to graph 0, 0, which does me absolutely no good, and then pi over 6, 3. So I'm going to have this point here, and then I'm going to mirror it over here. And then I'm going to have pi over 3 about 5.2. So right about there, mirroring it right about there. Then I'm going to have pi over 2, 6. And then when I do 11 pi over 6, which is down here, it tells me it's negative 3. So 11 pi over 6 is this angle here. I'm going to flip over and get that same point that I already have. And when I do 5 pi over 3, that's negative 5 pi over 2. So here's 5 pi over 3, but it's negative, so I'm going to end up getting that angle. And then 3 pi over 2, negative 6. So here's 3 pi over 6, hopping the pole, negative 6. And I can check it on my calculator, but I'm going to end up getting this off-center circle. And it's supposed to look like a circle. So that's the way that I use symmetry as a guide, is I only, because it was a sine curve, only graph the first and the fourth quadrants. Okay, the next one is a cosine curve, which means that it is going to be symmetrical with respect to the polar axis, which means this line right here. So whatever I graph on the top, I will also graph on the bottom. I am going to, in order to graph this, I am only going to pick points from the first, because you always pick points from the first. And the other quadrant I'm going to do is the first and the second, knowing that I can map them down to the third and the fourth. So I'm going to do 0, pi over 6, pi over 3, pi over 2, and then just keep on going. So I'm going to do 2 pi over 3, 5 pi over 6, and then finally stopping with pi. So I'm going to do these. So I'm going to do 4 times the cosine of 0. So they'll end up being 4 times 1. So this will be 4. Then I'm going to do 4 times the cosine of pi over 6, which will be 4 times the square root of 3 over 2, which will be 2 times the square root of 3. I'm going to do 4 times the cosine of pi over 3. So that'll be 4 times 1/2, which will be 2. Then I'm going to do 4 times the sine. Oh, God, why did I say sine? Cosine. 4 times the cosine of pi over 2. The cosine of pi over 2 is 0. So 4 times 0, this will be 0. I don't know why I drew that extra line in there. So this is 0. And then now I'm going to do 4 times the cosine of 2 pi over 3. So this will be 4 times negative 1/2, which will be negative 2. And then 4 times the cosine of 5 pi over 6. So 4 times the negative 1/2, which will be negative 2. And then finally 4 times the cosine of pi. So this will be 4 times negative 1, which is negative 4. Now plotting those points, I'm going to do 0, 4. So 0 degrees 4. Applying that point on the other side, I am going to be 1, 2, 3, 4. Then I'm going to do pi over 6, 2 pi over 3. So pi over 6, 2 pi over 3. The decimal equivalent for that, should have done that before, so sorry. And that's going to be about 3.5. So pi over 6, 3.5. So 3.5. And mirroring that. And then I'm going to do pi over 3, 2. Pi over 3, 2. Mirroring it. And then I'm going to do pi over 2, 0. And then I'm going to do 2 pi over 3, negative 2. So 2 pi over 3, negative 2. So here's 2 pi over 3. Now I'm doing a negative 2, so I'm going to go over here to negative 2. And then I'm going to do 5 pi over 6, negative 2. So 5 pi over 6, negative 2. And then finally, I'm going to do pi negative 4. So pi negative 4 will match here. And then I'm going to connect the points. Now when I graph these points, so when I graph 0, 4, so 0, at 0 I'm going to do 4, and then I'm going to reflect over this line, but it's on the line so I can't really reflect it. Then the next one is pi over 6, 3.5. So pi over 6, 3.5 would be about here, and I'm going to reflect it over this line, so I'm going to draw this point there. The next one is pi over 3, 2. So pi over 3, 2, reflecting it, pi over 3, 2. Then I'm going to do pi over 2, 0, 0. And then when I go to do this, 2 pi over 3, negative 2. So here's 2 pi over 3. When I do the negative, I'm going to end up with this point here. When I do 5 pi over 6, that's this angle here, negative 3.5. And then finally, oh, I wrote that wrong. And then pi negative 4, which is this. When I sketch this, I can check my calculator to get a better picture of it, but it's going to be a circle off to the side like that. Okay, looking at the next one, 15 and 16 tell you that it's a rose curve, so you're still going to answer some questions first, and then you're going to go ahead and graph using those rules that we learned in class. So the first thing is this is cosine, so I'm going to say it's symmetric, 2 m's, over the polar axis. That's the first thing it's going to ask me. The second thing it's going to ask me is it's going to ask me to find the theta values where r is equal to 0. So I'm going to say 0 for r is equal to 3 cosine 2 theta. So divide both sides by 3. 0 is equal to cosine of 2 theta. I'm going to sort of ignore the 2 theta right now, and I'm going to ask myself, when is the cosine equal to 0? Well, the cosine is equal to 0 at pi over 2 and 3 pi over 2. That's one lap around the unit circle when the cosine is equal to 0. Now I'm going to set that equal to whatever's in here, which is 2 theta. So I have pi over 2 is equal to 2 theta, and 3 pi over 2 is equal to 2 theta. If I divide both sides by 2 or multiply by 1/2, I'm going to get pi over 4 and 3 pi over 4. So I'm going to say my zeros are going to be 0 pi over 4 and 0 3 pi over 4. If I want to use symmetry as an aid, if I do 3 pi over 4, which is here, if I do 3 pi over 4, which is here somewhere, if I have a 0 here, I'm also going to have a 0 down here. So I'm probably going to have zeros at 5 pi over 4, because that's the one that I reflected, and then 7 pi over 4. So those are going to be all my zeros. You only need to list these two, and I'll be happy. Then, so that answers the next question, and then it wants to find the max and the min. So then I'm going to ask myself, well, it's a rose curve. So my max is going to be whatever number comes out in front. So my max in this case is going to be 3. So my max will be 3. My min, I don't think it asks, but my min will be negative 3. To find out when that occurs, I'm going to ask myself, when does the cosine normally equal 1? And the cosine normally is equal to 1 at 0 and then again at 2 pi. So I'm going to say 2 theta is equal to 0. Oh, no. Yeah, I'm right. Why did I pause? 0 and 2 theta is equal to 2 pi. Divide both sides by 0 and I get theta is equal to 0 and theta is equal to pi. So my max of 3 is going to happen at 3, 0 and 3 pi. So I'm going to, so 3, 0 would be here. 3 pi would be here. Then I'm going to go up and ask myself, how many petals do I have? Well, 2 theta is the number that's inside. 2 is even, which means I have twice as many petals, so I have 4 petals. Remember, the petals are equally spaced. So if I take 4 petals and I take either 2 pi and realize that they're pi over 2 apart, or if I don't like radians, I take 360 degrees and divide it by 4. They are going to be 90 degrees apart. I already have 2 here. So if I go 90 degrees or pi over 2, the next one's going to have to be here, Here's another pi over 2 or 90 degrees, and then the last one's going to be here. That accounts for my 4 petals. And there are my 4 petals. Okay, moving on to the next one. Next one is a sine curve, so I know it's going to be symmetric to the line. Theta is equal to pi over 2. To find my zeros, I'm going to say 0 is equal to 7 times the sine of 5 theta. So 0 is equal to the sine of 5 theta. I asked myself, when is the sine equal to 0? And that happens at 0 and pi. I'm going to set equal to that 5 theta. So if I have 0 is equal to 5 theta, 0 is equal to 5 theta, theta is equal to 0. So 1, 0 is going to be 0, 0. And then if I have pi is equal to 5 theta, then divide. So pi over 5 is also going to be a 0, which is 0 pi over 5. Remember, my zeros really don't help me graph, but I found them. Then to find my max is going to be that 7. My min, in case I wanted to know, is going to be negative 7. To find the max, I'm asking myself, when is the sine normally equal to 1? Well, the sine is normally equal to 1 at pi over 2. I might as well find my min too. Oh, and so I'm going to say, well, I'll just do it this way. So then I divide both sides by 5, and I get theta is equal to pi over 10 multiplied by 1/2. I might want to change that to degrees. So I can, because I think you guys do much better in degrees. So if I take pi over 10, multiply it by 180 over pi, I'm going to get theta to equal about 18 degrees. And I'm going to pause and check my mental math. So my mental math was right. So at pi over 5, so I'm going to have a max of 7 at pi over 10, which again is probably working better in degrees, 18 degrees. So 18 degrees would be a little bit more than 1/2, and we said 7, so that's going to be here, a little bit more than 1/2, so I have this point here. Remember that we just said it's symmetrical to the line pi over 2, so I'm going to have that exact same reflection over here. So I have at least 2. Well, it's 5 theta, so I asked myself, 5 theta, it is odd, which means there are going to be 5 petals. So to find out how much distance is between each petal, I can either take 2 pi and divide it by 5, which probably isn't going to help most of you a whole heck of a lot, or I can take 360 degrees and divide it by 5. And if I take 360 degrees and divide it by 5, I get 72 degrees. So there's 72 degrees between each of these petals. So if I started at 18, because there's my first one at 18, right there, and I take 18 and I add 72, the next one is going to be at 90 degrees. So I'm going to put a petal peak at 90 degrees. So when I add 72, because I'm going to add 72 each time, when I add 72 to that 90, I get 162, which I believe is this one that I have right here, because the 5 pi over 6 is 150, so that kind of looks about right. Then I'm going to add 72 again, so I'm going to take 162 plus 72, and I'm going to have 234. So 234, this is about 240, so I'm going to do 234, which is about here, just an estimate. Then I'm going to add 72 again. So when I add 72 again, I get 306. So this is 315. 306 would be about here. And then if I'm having a good day, I don't know that I am, when I add 72 again, I should get 378, which is a coterminal angle for this guy right here. So I have all 5 of my petals, so I'm going to just draw my petals. So I think working in degrees will be a lot easier for you to do because you're more comfortable with adding 72 than adding, what was I going to have to add? 2 pi over 5? Yeah, I think you're much better at that. So change it to degrees and just graph. All right, the next one we have convert each equation from rectangular form to polar form. I'm going to go ahead and simplify this first and make this x squared minus 4x plus 4 plus y squared minus 4y plus 4 is equal to 8. I'm going to rewrite it as x squared plus y squared minus 4x minus 4y is equal to, and the 4 plus the 4, set it equal to the other side, that's going to equal 0. I wrote it like this purposely so I can change this x squared plus y squared directly into r squared. Then this will be minus 4r cosine theta minus 4r sine theta, and that's equal to 0. I am going to put this one r on its side by itself, so I'm going to add the 4 cosine theta to both sides and add the 4 r sine theta to both sides. At this point, or you could have done it earlier, doesn't really matter, I'm going to divide everything by 1 r, because that's what I have in common from all three terms. I'm going to have r is equal to 4 cosine theta plus 4 sine theta. And again, I've gotten rid of the x's and y's, replaced them with r's and thetas, so that is good to go. The next one is pretty much the same thing. I'm going to do x squared minus 4x plus 4 plus y squared plus 2y plus 1 is equal to 5. Writing the x squared plus y squared together, minus 4x plus 2y, and then the 4 plus the 1 is equal to 5. When I subtract it from the other side, I get 0. This I'm going to make r squared is equal to, oh, skipping a step, r squared minus 4r cosine theta plus 2r sine theta, just replacing the x and the y with the r sine and r cosine. So now I'm going to say r squared is equal to 4r cosine theta minus 2r sine theta. Divide everything by r, 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 and I'm going to get r is equal to 4 cosine theta minus 2 sine theta. Okay, doing the next one, I'm going to do the same thing. I'm going to do x squared minus 3, oh no, it's minus 6. Minus 6x plus 9 plus y squared is equal to 9. I'm going to write the x squared plus y squared together. Minus 6x, subtract 9 from both sides and get 0. So I'm going to have r squared minus 6r cosine theta, replacing the with my properties, rules. So I'm going to have r squared is equal to 6r cosine theta. Divide both sides by r. And I'm going to have r is equal to 6 cosine theta. The next one, I'm going to do the same thing. X squared minus 4x plus 4 plus y squared plus 4y plus 4 is equal to 8. Put the x squareds together. Minus 4x plus 4y. The 4 plus the 4 is 8. Minus 8 is equal to 0. So this is r squared minus 4r cosine theta plus 4r sine theta, just replacing the x and y's with r cosine and r sine, and the x squared plus y squared with r squared. I can divide by r here or put everything on the other side. I think it's just easy to put everything over to the other side. So I'm going to have plus 4r cosine minus 4r sine. Divide everything by r, r, and I'm going to get r is equal to 4 cosine theta minus 4 sine theta. Okay, the last set of problems we're going to start now. And the last set of problems is converting equations from polar to rectangular. So remember, in order to rewrite r, I need to have r squared, and then for the trig function, I need like r cosine or r sine to make that either x or y. So when I'm looking at the first one, number 21, I'm probably going to rewrite that a little bit. So I'm going to say r is equal to 4 tangent is sine of theta over cosine of theta. And then secant is 1 over cosine theta. So I'm going to think of this as r is equal to 4 sine theta, and then I'm going to rewrite this as cosine squared theta. In order to get, so that didn't do anything for the r. So what I'm going to do is I'm going to multiply both sides by r. So I'm going to multiply this side by r. And when I multiply this side by r, I'm multiplying by r over 1. So this will be r squared is equal to 4r sine theta. And the r only goes in the numerator, not the denominator, over cosine squared theta. Well, I'm going to take my time doing this one. I'm going to have r squared is equal to, this r sine theta will be y. So I'm going to write 4y over cosine squared theta. In order to get rid of that cosine squared theta in the denominator, I'm going to multiply both sides by cosine squared theta. So I'm going to multiply this by cosine squared theta. Now I'm going to have r squared cosine squared theta is equal to 4y, because these will simplify. And I can think of this as r times the cosine of theta and this whole thing squared, because they're both squared. So in order for me to do this, they both have to be squared. So this is going to be x. So I'm going to say x squared is equal to 4y. If I divide both sides by y, or 4, I'm going to say y is equal to x squared over 4. Okay, moving on to the next one. I have r is equal to the tangent theta secant theta, which is basically the same thing as this. So I'm going to do it the same way. I'm going to say r is equal to 5 times the sine of theta over cosine of theta, and secant is 1 over cosine of theta. So I'm going to think of this as r is equal to 5 times the sine of theta over cosine squared theta. I'm going to do that same thing that I did before. I'm going to multiply this side by r, multiply this side by r, but remember that's r over 1. So I'm going to have r squared is equal to 5r sine theta over cosine squared theta. I'm going to do two things at once in this step since we just kind of did this problem. I'm going to multiply both sides by cosine squared. And then I'm going to change this r sine theta to y. So I'm going to have 5y is equal to r squared cosine squared theta. Well, since they're both squared, I can make this x squared is equal to 5y. Y is equal to x squared over 5. And that is my final answer. So same as the one before. So r is equal to sine of theta over cosine of theta times 1 over cosine of theta. So I am going to think of this as sine of theta over cosine squared theta is equal to r. Choosing to eliminate, I'm going to multiply this by r, multiply this side by r. I'm going to have r squared is equal to r sine theta over cosine squared theta. So I'm going to have cosine squared theta, or r squared I'll put in front of that, is equal to y, because r times sine is y. So I'm going to have x squared is equal to y. And finally, the last one, basically the same thing except for it's reciprocal. So I'm going to say r is equal to 2 cosine theta over sine theta times the reciprocal of cosecant, which is sine theta. So I'm going to have r is equal to 2 cosine theta over sine squared theta. Multiply both sides by r. I'm going to have r squared is equal to 2r cosine theta over sine squared theta. I'm going to say r squared times the cosine, sine squared, times the sine squared theta is equal to 2, and then in place of this r cosine, I'm going to write x. Then again, this is the same thing. I can think of this as r times the sine of theta. This whole thing is squared. So y squared is equal to 2x. And I can write it as x is equal to y squared over 2. I'm not going to take the square root. I'm just going to solve for the variable that's not squared. All right, so I hope this helps, and we will see you next time in class.